Hello and welcome to AWS Made Easy. This is the show where we interview guests from AWS. We talk about the latest AI, AWS, FinOps news, cost optimization, and we try to give you our opinionated insights, especially on how to sort through all of this stuff. My name's Stephen Barr.
Hi everyone, I'm Rahul Subramaniam, and welcome to the show. I know we've been a little busy with a bunch of stuff going on, but we couldn't be more excited about this episode. We have so much going on at this end, Stephen. What's been happening at your end?
I think we're at the part of the exponential curve where it turns from a ramp into a cliff, and it's so exciting, but there's just so much to keep up with. So and things that came out, a month ago or a month and a half ago, like, oh, you're still using that? That's ancient. Might as well use Morse code.
Yeah, actually, in this, on this show, we've always used the word that we stand in front of this fire hose of AWS announcements all the time. And I was just on a call earlier with my team, and we were just discussing that it now feels like we are in front of a tsunami, coming in from all directions, because there's all the stuff that's already coming in from the AWS world, there's stuff coming in from the AI world, and then to make sense of all of it and figure out how to make it all work in the real world. Because the sheer number of requests and the demand for doing something in AI is so vast that it's I don't think there's ever been a time like this in my entire career that spans multiple decades. So
nothing moving so quickly, right?
Exactly.
Before you'd think, okay, something that came out 6 months ago is still new, and now you can have an entire arc of a product,
correct,
be start to finish within that 6 months, have it be useful and serve a purpose, and then be done with.
I think 6 months is still a very, very long period. I mean, here we are already at an age where shipping a product within a week to 10 days is kind of the norm. And then you should imagine that in 6 months' time that there's literally no moat around your applications anymore. And anyone can basically spin up a version of your app in a couple of weeks. And that's kind of the life cycle right now. So there's a lot to think about. There's a lot to go through and figure out what patterns emerge out of this.
Definitely. Well, let's jump in to the first AWS announcement. We've got a couple of AWS and also just AI announcements to cover. I'm going to put this on screen and we're going to go over these. And then, as part of this, give our thoughts. We give a rating 1 cloud to 5. We say, does this simplify or is this complexifying your life? Should you implement this? Should you wait? So let's have a look. The first one is going to be DeepSeek R1. Let's put this on the screen.
Yeah, this is a big announcement, and I think even Andy Jassy posted about it. This is actually pretty neat. So till very recently, you could only run DeepSeek kind of in SageMaker mode, where you had to launch your own instances and kind of run it locally. They didn't make it easy, but it wasn't a fully managed service. And now you have DeepSeek R1 literally on demand. So it's fully managed. You literally just pay by the tokens. Super easy to use, as is everything else in Bedrock. So now that you have a frontier model, a state-of-the-art model available to you in Bedrock with just a few clicks is pretty awesome.
Have you used DeepSeek very much? How is your experience compared to the Claude and the latest ChatGPT?
Yeah, so honestly, for the kinds of use cases that we've been looking at, whether it's coding, whether it's stuff related to education and things like that, we generally find that Claude 3.7, which got announced after DeepSeek R1, they are now kind of on par. So whether it comes to coding skills, whether it comes to creating plans, thinking through complex problems, I find that both DeepSeek R1 and Claude 3.7 are roughly the same. It's becoming harder and harder to distinguish between these models on their capabilities. I think unless you have esoteric use cases which are pushing the boundaries of understandability, like, for example, if you're doing a very hard math problem and you needed to really understand the core concepts of it, I mean, most of these models right now, the frontier models, are able to actually solve it pretty easily. But yes, there is a class of math problems that these models are still struggling to kind of achieve good fluency with. And I think for 99% of the use cases we have, we are at a point where these just get solved. So
have you looked through the
awesome.
questions in, I think it's called Humanity's Last Exam?
No, I haven't. Let's bring that up.
Yeah, I'm going to. It's really neat. It's one of the metrics that they look through. Let's really put this on screen. And I think that what's important with this is that it's showing you the kind of questions that AI is now being graded on. Mm-hmm. And so this is called the HLE. So when you see these scores, the accuracy score here is GPT 4.0, 01, Sonnet 3.5. And this is a collection of questions that have been put together by expert humans, 500 institutions, 50 countries. So here's an example. What does this Roman inscription mean? Here it is. Or another one. Yeah. Hummingbirds with apodiforms uniquely have bilaterally paired oval bone. About other stuff. How many paired tendons are supported by the sesamoid bone? Answer with a number. So lots of interesting kind of deep questions here. It's a lot more than what you would think. I think this would surprise people. We think, wow, this is relevant. And so looking at DeepSeek R1, we've got the 8.6 on the accuracy, 81.4 calibration. So Claude 3.7 Sonnet, a little bit higher on the accuracy, much higher on the calibration.
Yeah.
So yeah, you're right. But they're in the same ballpark. Gemini thinking is lower on the accuracy, 3.5 Sonnet. It's amazing with the jump from 3.5 to 3.7 Sonnet.
Oh yeah, totally.
So yeah,
at least for most of our day-to-day use cases, we are finding that these models are starting to converge. Like it's very hard to tell them apart. The other interesting decision point, like we are always looking, or let me step back. 6 months ago, we were in a situation where as soon as the new model came out, the jump in capabilities was high enough that you'd be like, let me go figure out how to leverage this other model. And you'd be switching between Anthropic and OpenAI and any of the other open source models that were available, whether it be Llama 3 or whatever. So you're constantly jumping. We are now getting to a point of nuance where a given prompt, if you just took it to another LLM, it might feel like it's not performing quite as well, particularly when the prompts are getting very, very large with the huge context in place. And it's not so much that the model is not so capable. It's the way you crafted your prompt in the first place for model number one doesn't necessarily translate to another model just exactly the same way across that massive prompt and context, because the architecture of the model is different. The way the transformers look at it is different. The way, the different layers are going to tokenize your prompt is going to be different. So there are multiple variables that come into the way the model architecture is there, where the exact same prompt is going to perform differently. So if you optimize this prompt to work really well in one model, you may not get the same results across another model, even though it's equally capable. You might have to tweak the prompt a little bit to be just as good on this other model. So I think it's becoming less a question of capability. It's becoming a question of how much instrumentation have you invested in at this point? And do you really want to overhaul and redo a lot of that to get slightly better results somewhere else, maybe?
And I think we've been mostly building towards Claude's flavor of doing things. Would you agree?
I think it's a combination. It's at what point of time did you actually make the investments? And across the portfolio, it kind of varies in multiple places. But I think at one point in time, Llama 3 was kind of the dominant model, open source model. And so there was a lot of stuff that was done around Llama 3 because that was performing better than Claude Sonnet 3.5 at one point for a bunch of use cases. But with 3.7, this one seems to be, we seem to be leaning towards 3.7 because slightly has an edge over, it has a slight edge over DeepSeek R1.
Well, I think we could go over this for a long time. Let's rate this article. How do we rate the announcement on a relevancy scale, on a usefulness, and also details? What do we think about this one?
100% simplifies. I think there's no doubt about it. The fact that you can just go to Bedrock and go to the playground, start playing with R1, and you get charged only by the token, couldn't be easier. So definitely simplifies. And I think this would be a 4.5.
I agree. It's getting a lot of publicity, and like we said, whether it's the nuances of the model itself, But the idea that you can immediately play with it, you just switch your identifier in, especially if you built towards the Converse API, you just switch your identifier, you get started,
Exactly.
you can immediately play with this. Great. Well, that is DeepSeek R1. Before we move into the next one, I wanted to mention I was at, you mentioned llama, so this reminded me. I was at a local meetup called Llama Palooza. And that was,
I remember seeing a post about it.
Yeah, a week and a half, 2 weeks ago. And it was amazing. They brought up this perspective that the llama paper that was 2 years old at the date of that event. And so going from a paper to a massive oversubscribed event and an ecosystem and code and all this cool stuff, it was really neat to see how quickly that evolved.
Yeah.
One of the sponsors there was Cerebras or Cerebras.
Cerebras. Yeah.
Yes.
Cerebras is a provider. There's actually a very interesting. They claim to have the fastest tokens per second performance of any customer anywhere.
They brought the actual wafer in, so they have a chip that's about this big. And for context, most people, if you open up your computer, your processor is going to be like a postage stamp, right? The actual core is about this big. Now with chiplets, it's about that big. Theirs is this, and they were showing inference at 2,000 tokens per second on Llama 7DB. It's really, really cool. And they think that when you're typing or thinking that humans operate at between 1.5 to 3 tokens per second. Yeah. And so they were doing 2,000 tokens a second. And so obviously if it's talking to you, that's one thing. But the cool thing, I think, is when they're talking to each other and different Cerebras-powered agents, they can get through a whole conversation in, for us, what would be a blink of an eye.
I think it'd be very interesting to see the hardware, the variety of hardware that's coming out to solve all these different AI problems. It's fascinating. All the custom hardware is actually revolutionizing things.
Well, and speaking about DeepSeek, a lot of people are talking about the new Mac Studio M3 Ultra with 0.5 terabyte of unified memory. People are saying that is just the right size to run a quantized version of DeepSeek locally.
Correct.
Which is pretty wild.
I looked at that, and there were a couple of experiments that I think some folks were trying out. I don't think, because it's a quantized model, I don't think it performs as well. And then your tokens per second is probably going to be in the 10 to 12 tokens per second, which, to be honest, the way we are kind of getting used to the speeds at which things are happening, particularly when you're subscribing to a cloud service for this, 10 to 12 feels really slow in comparison.
Yeah, and for the cost, right, the fully optioned up Mac Studio M3 is about $15,000.
Something like that.
So to make that investment, that's a lot of inference on Bedrock.
Correct.
Obviously, if you have to have it locally, and that's a non-negotiable requirement, then you have to do what you have to do, and that's probably a good option. But I would weigh that against how much inference you can do for $14,000 on Bedrock.
Correct. Now, I think Bedrock would be the easy choice in almost every scenario.
Yeah. And I'm saying, I love nerding out in hardware. I've got hardware all over here. But it would be really hard to justify that level of capital for something that isn't there yet. Or for something that could, like you said, barely operate at tolerable speeds. And tying that capital up for the life of that machine might be 2 or 3 years. Bedrock's going to go through several upgrade cycles during that time.
That's correct. That's absolutely. And the models are getting bigger and bigger. So, the next big model that comes in, you might not be able to fit it into that huge investment that you just made.
Yeah, what happens when Llama 800 comes out? All right, Let's check out this one. Speaking of Bedrock, that's on screen here. Bedrock now supports multi-agent collaborations. This was announced March 10th, so 2 days ago. The GA of multi-agent collaboration for Bedrock, allowing developers to create networks of specialized agents that communicate and coordinate under the guidance of a supervisor agent. Okay.
Right. So this is basically, now we've talked about Bedrock agents multiple times on this show. We've done demos, we've done sessions where we built agents of our own. Now you can have multiple agents kind of talk to each other. It kind of takes me back to, I think we did we not do an episode on AutoGen quite a while back, where there were different architectures by which agents could kind of talk to each other. This is kind of similar. This is a cloud hosted version where you don't have to do anything. You can just go in and say, here are the different mechanisms by which the agents can collaborate with each other, and it's relatively straightforward.
Now, I think the most important thing to remember about Bedrock agents, because it isn't as easy to use as, say, doing everything on Claude tool use. But
True.
the difference is that with Bedrock agents, the actual execution is being done in Lambda. And so whatever security, whatever resources, because all the other frameworks, they tell you, okay, here's a tool that you can run. Here's the call this function with these arguments. But you still have to call it locally. Or, you can call a Lambda yourself. But with Bedrock agents are actually running on Lambda by default. So you can manage the security, you can manage the resources a lot easier.
Yeah, and that's also a double-edged sword, because you do have to manage a bunch of other stuff and make a bunch of other decisions that you might not have had to make elsewhere. So, but it's definitely something worth looking at. If you have tons of agents that are based on Bedrock, where you have tons of your data already sitting in AWS, Bedrock agents is a great way to go.
I'm putting up this on the screen. They're showing the example they use is a supervisor agent, which takes questions about, in this case, a mortgage. Mm-hmm. And they have collaborator agents that may have access to different databases, data sources. There's one that's for existing mortgages, for new mortgages, handling general questions. And each one can have, access to tools, action groups, knowledge bases, and guardrails. Correct. And supervisors make the plan across all of the other agents. So this is we just went to general availability. Here's the documentation. There's a lot there. Have you found the new AWS layout where they have I always click on this as the next page. It's not the next page. You have to go down to here, to the next topic. Here's what's supported for multi-agent collaboration. Haven't added 3.7 Sonnet yet.
Actually, that is an interesting one. I haven't seen 3.7 Sonnet added to a lot of this stuff. I would have expected it would be available almost immediately.
Yeah. That being said, Nova Pro is there. I'm reaching for Nova more and more often, just to stay familiar with it. I don't think it's at the level of 3.7 or even 3.5.
Would you say Nova Pro is about 3.5 Haiku or even 3.5 Sonnet?
I say it's in the middle.
Okay.
That's my guess. But it's certainly a very worthwhile contender, and for the price, you should definitely reach for it. And I also reach for Nova Micro a lot versus Haiku. Okay. For very, very simple things, why not? It's the cheapest and it's really fast.
Yeah, I think we should do another updated episode about Nova. We haven't really done any deep dive into it. And I'm not even familiar with any new updates that have come in the last month or so. So we should probably do a session on that.
Okay. All right. We will. That sounds good. Looking at the multi-agent work, they're showing how you can sign in on the console. They've got lots of documentation. I think we have to go through this in detail to see exactly how easy it is, but they've got orchestration strategy, Lambda functions. It seems like a pretty natural extension of what's already there. But I think we should go through this in detail on its own episode. On the face of it, what do you think of this announcement?
So I like the announcement because it simplifies and it solves a problem that exists. Everyone is building agents, and now you need to start orchestrating a bunch of agents together to get something real done. So I like the simplicity or the simplification of it. So I'd give it a simplifies. However, as a service, I think this could have been way simpler. Like, given that Bedrock came out way after AutoGen, Crew AI, and a whole bunch of these agent orchestration platforms, I think they should have learned a little bit about the kind of UX that works. And unfortunately, they've gone back to some of the more complex mechanisms of deploying the service or even starting to use the service with this. And that's not something that I get very excited about. So I want to be a little blunt and give this 2.5 stars. It solves a problem, but this could have been way easier. Like I give full credit to teams like the latest Aurora one that we
DSQL.
discussed, the DSQL, right?
Yes, that was so. That should set the standard.
You
for how
have to give
easy
credit where it's due, and they did amazingly there. And when I look at this, I'm like, why? Like, it could have been so much simpler.
Yeah, I agree. It's very fun to kind of nerd out on the complexity part, and you feel smart, and you look at all these different bells and whistles and switches.
Correct.
But you don't necessarily want that.
The minute I see a JSON configuration that looks the way it does right now, it all automatically now sets off red flags.
So you're saying one of these?
Yeah.
Yeah, there's a bit there, and you're gonna have to go through this entire data model.
Correct. And none of those terms are simple, straightforward. It's not a tiny JSON configuration. It's a very complex data structure that you're putting in over there.
Interesting. All right. Well, let's do a deep dive into this one, and we will figure out this. But yeah, on the surface, it seems complicated, and I want to use Bedrock agents more, but it's not my go-to when I'm just in cursor going as fast as I can. And I think for that reason that there is a bit more of a heaviness to it. And that being said, it supports a much more advanced use case, running on Lambda and doing all of that stuff. So it would be worth it for a production system, but I wish it was easier to kind of hack on.
Yeah. So my point there is that even though it's more complicated use cases and stuff like that, it can all be hidden behind the scenes. I don't think anyone really cares that it runs on Lambda versus an EKS cluster or whatever else. Like the beauty of the DSQL, for example, right? It just runs. You can run at infinite scale. Now, that might be running in Lambda. Who cares, right? That's the beauty of, creating a simple UX for customers. And I think this is very similar. I don't think anyone really cares whether the multi-agent collaboration actually runs on Lambda or somewhere else, as long as you let it do what it does and you manage it for everyone.
All right. Well, for now, we will give it a simplifies 2.5 stars. Now, we're always
being harsh, but
no, we're willing to be proved wrong, and so I think we should come back to this one, do a deep dive.
Yeah.
Maybe we will lower it. Maybe we'll raise it. So let's give it a shot. Good. Okay. Next one. Speaking
on
of
that
Bedrock,
note, actually, next one, should we pick up the common question that everyone, has been asking, which is
yes.
MCP versus, the other options right now, OpenAI's latest announcement with their new agent framework, as well as, a bunch of other options that are out there. So why don't we bring up that question, and you might articulate it better than I do.
Okay, well, one question that I've been getting a lot, and I don't know the perfect answer for it, is how do all these different frameworks fit together? So we have MCP, which is driven by Anthropic, Model Control Protocol, and that is a way.
It's a Model Context Protocol.
Model Context Protocol. It's okay. Well, that's for agents to talk to each other or talking to different services. How does all this stuff fit together? OpenAI just had a new announcement yesterday about new tools for building agents. Here we go. Let me put this tab up. This was just launched yesterday. Oh, I see the screen isn't there. Here it is. New tools for building agents. That was launched yesterday. A set of building blocks that will help developers and enterprises build useful and reliable agents.
Yeah.
So we've got this. We've got Bedrock agents. We've got MCP, which isn't exactly the same thing, but how does that fit in? So, Rahul, what is your understanding?
Great.
Can you help us divide this ecosystem and compare apples to apples?
Great. So let's start with some key terms that we need to understand. So we've got the LLMs, right? Everyone understands now what these LLMs are. Now, one of the very interesting capabilities of these LLMs is what is called tool calling, okay? Where you can say, I have these endpoints, and you give the LLM a certain JSON, and the mechanics is actually fairly simple. The client that's actually hosting and running the LLM, maybe a chat client or whatever, that basically passes on a little JSON configuration that says these tools are available to you. Now, the tools could be an API call that is external, or the tool could be a browser run, or it could be an API call into some third-party system like a Zendesk or a Salesforce or whatever you want, right? So now that is tool calling, and that's a pattern that's available on OpenAI's models. It's available with Claude. It's available with a few other open source. It's available in Gemini. It's available in a few other open source tools, open source LLMs as well.
And you can use the Converse API. You hand it a list of tools, and the LLM picks the list of tools. Exactly. And from the client's perspective, it's just which function do I call and how do I call it?
Correct. Now, the mechanism of calling this function is also very interesting. The mechanism basically is that the LLM basically decides that, hey, I could do a better job if I could make this tool call and get the answer for this question. So the call with the parameters, the definition is provided in the JSON, and the LLM decides, I want to make this call with these parameters and I want the answer back. But the LLM has no capability to make this call. So it tells the client, why don't you make this call on my behalf? And whatever the answer comes back, give it back to me, and then I'll proceed from that point on. Okay. So that's the tool calling pattern that exists across all of these different hosted versions of the LLMs. Okay. Clear so far?
Yes. So as an example, say if you wrote into the LLM, I'm going to San Francisco tomorrow for 3 days. Should I pack my umbrella? Okay, well, it has to figure out, well, what day is tomorrow? I don't know. So what day is today? I can use a tool to get the date.
Correct.
Then I could say, well, I don't know the weather in San Francisco. I was trained up until October of 2024. I have to use the Get Weather API, which takes a zip code. Well, I do know the zip code of San Francisco. I'll turn in the Get Weather API, and it's looking like rain. You should pack an umbrella.
Correct.
So it's figuring out, okay, I need to know the date and I need to know the weather in order to make this judgment call.
And it might even be a web search. So it basically significantly enhances the capabilities of an LLM to actually solve problems. So this is called the external tool calling. Now, what the MCP protocol did is it's basically saying that and of course it's led by Anthropic, but it's open source and they've declared the whole protocol. It is the challenge over here is that you actually have to hand construct this JSON that describes how an API is called. It has the details of the parameters of the API, the types of the API, how it is being called, and what the response types are going to be. And it has to then package this all up into it can get to be a fairly complex JSON object that is then passed on to the LLM as part of the configuration. That's not a great idea. There's just a lot of room for error over here. So what the MCP protocol does is that it basically says, here is how, if you had an MCP server and a client, the MCP server exposes an external tool in a very standard protocol way. And then you have the client side, which is what the LLM interacts with. And the client knows how to call the MCP server. It knows exactly what parameters to call it with. And it also knows how to inform the LLM about the tools that are available to it. So you never have to tell the LLM, hey, here are all the tools. Here's the list of tools. You go figure it out. So this whole tool handling mechanism is nicely wrapped up in this beautiful protocol called MCP. And it's becoming really, really popular because it solves a very, very complex and common problem that people have, which is deciding how to package up a certain tool and make sure that it is communicated to the LLM in the right way so that it knows how to use it the right way.
So when you were using standard tool calling, you would have to basically have some way of describing exactly the entire space of inputs for every function. And there's things that you could use Pydantic, for example, and have these types that kind of described what the input looked like, but it wasn't locked down enough, right? Like if you had a day field, you couldn't say, you say it takes an integer, but you wouldn't say, okay, this integer is between 1 and 31. That would be a little bit harder to enforce.
Correct. There's too much variability in all of this, and the LLMs don't do a great job of processing all of this stuff. So by standardizing it and putting it under the MCP protocol, they actually made life very easy for everyone. And now you see this massive explosion of MCP servers, and there are tons of MCP clients now that support these MCP servers with a very simple protocol that underlies all of this. So that's been awesome, right? Now, what do you do with it? Ideally, you want to write an agent. And when the agent has to do something specific, you should just write up the agent as an MCP client that talks to an MCP server, which is a set of external tools, and is able to leverage those tools to do what it needs to do. So, for example, if I have an agent that has to respond to Zendesk tickets, Then all the Zendesk KPI are available via an MCP server. Your agent as the client literally just says, I'm going to use this call, and everything else around tooling is automatically handled for you. Okay. So think of the MCP actually being a layer below the agents. It's a utility function, it's a utility capability where any agent that's written and it needs external tool calling, or you want to enhance it with external tool calling, you can use the MCP client. That allows you to connect to a server automatically under the hood without having to worry about how do I tool it, what LLM am I dealing with. All of that stuff is just completely under the hood.
Okay, so that's a great way of saying they're at different layers. So on the one highest level, you have agents, which is a LLM that's purposed for a particular thing. So you say, okay, I've got my social media posting agent, and that has access to things I've posted before, and what it has access to externally, that's done via tools, or ideally via something like MCP, where it can be it's much more simplified how it can use the tools it has access to.
That's correct. Correct. So you've got this agent layer. Now, Bedrock has a set of agents. OpenAI just declared a whole new set of, a whole framework. But unfortunately, this framework is still using tools. So you still, pass on a set of tools that are available. They've made it easier. They've just bypassed the MCP part of it because it's a competitor's framework. So they don't want to be seen dealing in that. But if somebody wrote a tiny little adapter that just passed, that just wrapped this tool calling as part of the MCP protocol, you could absolutely use. There's no reason why you couldn't use this framework with an MCP-based tool.
That makes complete sense.
Right?
Okay,
well, and so there's that. And then Amazon, of course, is doing its own thing with tooling.
Yes.
I think very similar to OpenAI. It hasn't really put in the bets with MCP yet, but I think they should, because Amazon would, by standardizing it and providing a whole marketplace of MCP servers, I think they stand to gain a ton.
And that's a really neat way of going, right? So you could say, I have an MCP server that takes some micropayments, and any LLM can talk to it and provide this great information. And be provided with this great information. There's no integration you have to do. Here's the URL and the protocol, and there's not much to do there.
Exactly. So that's basically how you distinguish between those three different things.
Awesome. Thank you. That's very, very helpful. Let's take a 1 minute break. We come back. We've got two more announcements. We've got Graviton in new regions, Graviton 4, going back to the cost optimization side, and also streaming games from Amazon at a new level. When we get back from the break, we'll be right back.
Some tools just find AWS cost savings and make you do all the work. Visualizing cost opportunities is great, but that's not enough. CloudFix, on the other hand, actually delivers those savings for you. And you don't need to worry, because CloudFix uses AWS recommended savings techniques. It fixes, not just finds. It's the easiest way to save money on AWS. It's 100% automatic and risk-free. And the best part of all, it works non-stop. Stop overspending on AWS and click on the link to start saving now.
Okay, we are back from the break. We wanted to do an announcement that we see all the time in AWS, but it's pretty neat. We wanted to highlight this. I'll put this on screen. This is a pair of announcements, but it's more about kind of what it symbolizes. CHG instances now available in AWS Asia Pacific, Mumbai region, and M8G now available in Ireland. So the 8G is the Graviton 4 series. Pretty neat. It's, again, 30% better performance compared to Graviton 3, which is 30% on Graviton 2, which is 30% on Graviton. So that accumulates. That is a great rate of return. That's a compound interest for you.
Correct.
So Graviton 4, let's see, 40% faster for databases, for web, 45% for large Java applications, and Graviton 3. It is really neat. We're in this cloud era, but it's still very much kind of thinking about new hardware. We talked about Cerebras earlier. There's a lot of innovation in the hardware space that's pretty neat, driving all this stuff. So what do you think about the Graviton 4?
Yeah, I think we spoke in depth about Graviton 4 during reInvent when they actually made the big announcement around this. And we spent a bunch of time talking about its capabilities, its architecture, and all of that stuff. So I think it's kind of no-brainer to switch over to Graviton because the big leaps that are coming in now are coming in on the Graviton instances. You don't see the same happening on AMD or on the Intel ones, and those are going to be more expensive in general. So if you can move your workloads into the Graviton instances and then get up to the latest generation of Gravitons, I think there's so much gains to be had. And particularly if you're on if you're not doing C or Rust or Go, it should be relatively straightforward to migrate your applications to actually run on Graviton. So I'd say give it a shot, try it, because the gains to be had, like we were just discussing, compounded 30% year over year, is a massive amount of gain.
Yeah, absolutely. It's a one-time cost that's probably just, at worst, like you said, changing a compiler flag, changing the name of the library.
Or just recompiling your Docker image in a lot of cases.
Exactly. Or even just pointing it at the new Docker image. You might already be ready.
Correct.
It might be that hard. And not just Graviton for EC2 instances, but Graviton for your Lambda functions. One mention on Cloudfix, we find Graviton eligible Lambda functions, databases, other managed services like Elasticache, like OpenSearch. There's a lot of Graviton. We will advise you to switch it over automatically when you can. And when not, we'll at least wave a big red flag and say, look right here, this is how much you could be saving. So if we can't do it automatically, we'll point you in the right direction. And in either case, it will worth looking into.
Correct.
The
I'm going to call out. Yeah, I'm specifically going to call out switching over to Graviton for all the managed AWS services. When it comes to managed services, the migration from whatever architecture you're on of all the data to a different architecture is just going to be managed fully for you. You shouldn't have to care about it. And if it fails, then it'll just roll it all back. You will never have service downtime. It's going to be awesome. It's going to be significantly cheaper and more efficient. So it's an absolute no-brainer to switch to Graviton for all managed services that give you that choice.
Yeah, absolutely. Especially databases. Actually, funny enough, we just published a blog post. One of the database types that we still see, and this is the exact opposite end of managed services, are EC2 instances running Windows, running MS SQL, which is, would it is fair to say this is the most expensive way to run a database on EC2?
Possibly.
Unless you want to run a database on FPGAs or something. I don't know.
No, I think the one case that I actually saw an instance recently was someone running MS Access on a Windows machine that was being hosted, and they wanted multiple different, multiple clients to actually connect to that MS Access.
Okay.
I don't know if you remember MS Access from back.
I can still picture the box and the logo, that big yellow pixelated key. Absolutely.
Correct.
I was in a place not that long ago that still had some access in production.
Yeah, so that is probably just a tiny bit worse and more expensive and low performance. But yeah, I think they're all pretty bad. Yeah,
so if you were running Windows, and then if you're running Windows on EC2 and then running SQL Server on Windows, here's your migration path. First, switch to Linux MS SQL. Right, and then there shouldn't be too much holding you back. I didn't know this, but you can run Linux on MS. You can run MS SQL on Linux.
Yeah.
Not every single feature. Like if you have some very OS specific integrations, you will need to deal with that. But for the most part, you should be able to switch over. And if you can't, figure out why.
Yeah.
And figure out if it's worth fixing those 2 or 3 things. And then, can you run on Postgres, or can you run on RDS SQL instead of running an EC2 instance?
Correct. Now, there's just so much gains to be had. I think, like we've always discussed, workloads on AWS are very inefficient. The way they're just run. A lot of folks run them as if they were running their local data centers. And that's not how you should think about these at all. So getting to the latest instance, getting to the latest Graviton, versions, that should be a big 2025 goal.
I like it. And you still have time. You still have 3 quarters left. Knock out those New Year's resolutions. It is not too late. And speaking of, let's see, how do we rate this one? The Graviton 4 announcements.
Yeah, so this is an old announcement. We were already, I'd say we'd given it a 4.5 when it first came out. I remember this. And it's neutral on the simplifies or not, because, again, it adds 2 more instance types to, this, 800 odd instances that we have right now.
Yeah.
So, I think I'd just give it a neutral on that. Though, in general, it's a good thing that we have this new service. So I'm going to say definitely a good thing. Just adds to the complexity because you're supporting all the instance types that you've ever created so far, 800 odd of them right now.
Yeah, but so start using higher level tools, start using Compute Optimizer, use CloudFix.
Use serverless. Start moving serverless so that you don't have to care about it and you're still reaping the benefits of everything running on Graviton, because Amazon runs everything, AWS runs everything that they have as managed services on Graviton instances.
Yeah, absolutely. Get to the point where you don't need to care about the architecture.
Exactly.
All right, we've got one more announcement to wrap up for today. This one is a pretty exciting one. Here we go. On screen, announcing Amazon GameLift Streams. This is pretty cool. So speaking of managed services, managed capability, allowing developers to stream games at 1080p, 60 frames per second to any device with a WebRTC-enabled browser. So WebRTC, that's a standard. Just a few clicks, upload games built with a variety of 3D engines, little to no modification, and stream from specific regions and immediately start test streaming. You can play AAA, AA, indie games over the internet in just a few seconds on PCs, phones, tablets, and smart TVs without waiting hours for a download.
That's pretty incredible. This is the next generation of app stream, I think, as we were just discussing earlier. It's remarkable that you can actually get this over the internet. Now, I'm not much of a gamer. I'm not playing, first-person shooter games and so on. But getting 1080p resolution at 60 frames per second just feels mind-bogglingly good.
And then it's bi-directional, right?
It is bi-directional, correct.
Like in a first-person shooter, if you shoot at some person, it has to figure out, well, would you have hit them or not, and deal with all the time synchronization. Is this an agreed-upon hit or a miss? That's a big deal to get that right, and to get that right at that graphics level. Right? I don't know. I'm not a gamer either. I know that some of the high-end gamers want 144 frames per second. I don't know if that's the equivalent of gold monster cables or not. But you can do 60 frames per second, 1080p. That's pretty good, I would think.
Yeah, I don't think I would realize the difference. Of course, I'm wearing glasses and my eyesight isn't that awesome, but I don't know if I would be able to actually figure out the difference between a 60 frames per second and a 144 frames. I don't know if I have the capability, but I would love to hear from the audience. What do you guys think? If there's any gamer out there, we'd love to hear your reviews about this new capability. Let us know. We're curious.
And especially, like I said, I know that dedicated gamers, they'll spend $5,000, $10,000 on a gaming rig. People like you or I who have, Mac Studios, Mac Minis, MacBook Airs, but we can still want to try some, if there's something really good, sure, give it a shot. Yeah. I don't want to do a full build out of a gaming rig.
Correct.
So this is neat. You could do that. You could stream it instantly, and as long as you have a decent internet connection, this seems pretty good. How do you rate this one?
I'm torn on this because I just don't know enough about this support. I love the simplicity of it, that you can just upload your game and it just deploys almost like AppStream. So I saw a lot of similarity between this and AppStream. So I think I'd give it a simplifies. I haven't tried uploading a game to see how easy they've made it. So I'm going to reserve my judgment on the number of clouds here. But I definitely say it simplifies.
Yeah, well, I'm looking forward as a consumer of this. Like I said, I don't want to build out a gaming rig. That is not my thing. But I wouldn't mind trying something once in a while, giving it a shot for half an hour. I think that would be good, and being able to get a good experience without having to do a whole other game build. Like my desktop machine is a Mac M2, which is now on its way to obsolescence. That's still a good machine. But yeah, I would rather let the cloud do it and just try it for an hour.
Agree 100%.
All right. Well, I think it's time to wrap this one up for the day. Thank you, audience, for watching. Please let us know if you have any questions. We are going to do a deep dive into MCP in an upcoming episode. We've also got David Hughes later in the week talking about GraphRAG systems compared, whether it be Amazon's GraphRAG. There's a lot of other ones. So we've got a lot of neat stuff happening. Actually, speaking of David, I will put this on screen quickly. Let's see if I can share this tab. Yes, this is David, who is doing a talk actually today, multimodal GraphRAG or critical topics in AI in production. Join Amy Hodler and David in the AI in production conference by the ML Ops community. I'll repost this on my LinkedIn so you can check this out, multimodal integration with associative intelligence. So David is the person to talk to for GraphRAG. We're excited to chat with him later in the week. All right. Awesome. Thanks again. Have a good one. And we will see you next time.
Awesome. Thanks, everyone. Bye.
Bye.